Beginning this week, I got a lot of phone calls from different electric truck drivers that their state of charge dropped during the last weekend. And in the Netherlands, it's beginning January, and the temperatures are going towards freezing. So it's 1 or 2 or 3 degrees Celsius at the moment. And what's happening is the truck is conditioning its own battery, even when it's totally turned off. There are a few brands that are doing that. So let's have a look at what the energy consumption is and what you can expect of the energy drop of the state of charge drop during such a weekend. I made a calculation tool, and I will explain it when I explain the calculation tool. So let's see, we have a 540 kilowatt hour gross battery capacity, of which 70% is usable, so the depth of discharge is 70%, which makes the usable battery capacity 378 kilowatt hours of battery capacity. This is a NCA, nickel cobalt battery, and that's important to know because every different chemistry has a different specific heating value. So we need more or less energy to heat up 1 kilogram of battery pack 1 degrees Celsius. So for an NCA battery, we need 830 joules per kilogram of battery capacity. So calculated, converted to kilowatt hours is 0.000231 kilowatt hours per kilogram of NCA battery to heat it with 1 degrees Celsius. Then what we want to know is how heavy is the battery itself. And again, we have different chemistries, and different chemistries have different specific weights. But let's say, and I made some assumptions, but let's say that an NCA battery is around 5.5 kilograms per kilowatt hour. Then we know then we can calculate what the total weight of the total battery package is. Because it's 540 kilowatt hours gross battery capacity times 5.5 kilograms per kilowatt hour, the outcome will be around 3,000 kilograms of battery. So we have 2,970 kilograms of battery capacity. Now, if I know what the battery in total weighs, I can also make already the calculation. What is the energy needed to raise the temperature of the whole battery pack with 1 degree Celsius? It's these 2,970 kilograms times the 0.00023 kilowatt hour per kilogram. And that makes up about 0.6848 kilowatt hours per degree Celsius for the total battery pack. Now, you can heat up a battery different ways. You can do it with a PTC, but you also can do it with a heat pump. Now, I know in this case, heat pumps are being used, and my assumption is that the efficiency of the heat pump is around 3. So when I use, to make 3 kilowatt hours of heat, I need 1 kilowatt hour of electricity. So when put 1 kilowatt hour of electricity into the heat pump, it produces 3 kilowatt hours of heat. And to warm up the whole battery pack with 1 degree Celsius, I need 0.6848 kilowatt hours of energy, not electricity. So what we can do is, if we know the electricity consumption, we know the energy consumption, we can divide it by the efficiency of the heat pump, and then we know what the electricity consumption will be. So it's the 0.6848 divided by 3 is 0.23 kilowatts. So I need 230 watts to let the heat pump work and make the battery 1 degree higher. But it's not 1 degree. Let's say that the outside temperature is 2 degrees, and the target temperature for the battery, just for standstill, is 5 degrees. So the delta between the outside temperature and the temperature we want to reach, the target temperature, is 3 degrees. Now, then we can calculate what the total energy consumption of the heat pumps will be. It's 3 degrees times the 0.23 kilowatts is 0.68 kilowatts, what I'm using on energy. Now, the last thing I need to know is what the time of the standstill is. Now, in this case, it's weekend, so Friday night we are putting away the truck, and on Monday morning we are starting it up again. This is 2.5 days or 61.5 hours. And if I know the energy consumption of the heat pump, I can multiply that with the amount of hours. Then I really know what the total energy, what the total electricity consumption was in the last weekend. So with the 61.5 hours times the 0.68 kilowatts of energy consumption, of electricity consumption, is 42.1 kilowatt hours in total. And if I want to know what the state of charge loss is, so what the amount of, what the percentage is that the state of charge dropped, I need to divide the total energy consumption by the total net usable battery capacity, which is 378. This makes 11.14% state of charge loss. And the end state then is 100% minus 11.14% is 88.86% state of charge. So in this case, my customer experienced a state of charge after the weekend of 88% state of charge. Now, this is for one type of trucker with one brand, but let's say that we have another truck brand and he's not using NCA, but is, for example, using the LFP battery. And then we can make the same calculation. Now, what I did, I picked the chemistry, made it LFP. LFP batteries have a higher depth of discharge, so a larger amount of the battery is usable for driving. So with the same gross battery capacity, 540 kilowatt hours, I now have 486 kilowatt hours of usable battery capacity. But the LFP has a higher specific heating value. So instead of 830 joules per kilogram, I need 1130 joules per kilogram. That's a lot more. So, and then I make all the calculations the same. And the specific weight is also higher of LFP. So I have not only I need more energy to heat up a kilogram of battery pack, but I also have more kilograms of battery pack to get to the same amount of gross battery capacity. So those two add up. Then the rest stays the same. So the efficiency of the heat pump stays the same. The temperatures stay the same, and the time stays the same. Then what I see in the end is that in this case, the total energy consumption during the weekend was 67.8 kilowatt hours, divided by the 486 kilowatt hours of usable battery capacity is 13.94% of state of charge loss, which that's why you end up with 86.06% of state of charge within this case. So, and all the parameters, they can differ from time to time. It can be colder, maybe there's a different target for the target temperature for the battery. The efficiency of the heat pump can be better or could be worse. The total amount of battery capacity could be different, but this is this is high over how it works. So when a truck manufacturer chooses to condition the battery of the truck, even when it's completely turned off, then you can expect those kinds of energy losses.